interference of pulses and superposition. Let us consider two pulses that are travelling along the same path. Here, two pulses in a spring will travel in opposite directions. Observe that the pulses move in their respective directions, but where they meet, the disturbance is more than the disturbance caused by any single pulse. The two pulses are said to interfere when they meet, that is, when they occupy the same space at the same time. In this case, the interference is constructive because the disturbances combine to give a larger disturbance. Constructive interference gives rise to a larger amplitude of the resultant pulse when two or more pulses meet. Consider a case where two pulses are on opposite sides of the spring. Observe that the pulses move in their respective directions, but where they meet, the disturbance of the medium is less than that caused by any single pulse. Here the interference is destructive, because the disturbances combine to give a smaller disturbance. Destructive interference gives rise to a smaller amplitude of the resultant pulse when two or more pulses meet. When the two pulses on opposite sides of the spring have exactly the same amplitude, the amplitude of the resulting pulse is zero. This leads us to the concept of superposition. Two pulses are superposed when they occupy the same space at the same time. In other words, the two pulses are placed one on top of the other. The principle of superposition is that when two pulses occupy the same space at the same time, the resulting displacement of any particle of the medium is given by the sum of the displacements caused by the two pulses. The pulses add up. If the displacement of a particle caused by pulse 1 is delta y1, and the displacement of the same particle caused by pulse 2 is delta y2, the net displacement is delta y1 plus delta y2. This is true for each of the particles. We can also conclude that the amplitude of the resulting pulse will be the sum of the amplitudes of the two pulses. Note that if the amplitudes are on opposite sides, one amplitude is positive and the other amplitude is negative. We can choose the amplitude on top as positive. When the pulses interfere constructively, the amplitude of the resultant pulse is the sum of two positive numbers, and hence is greater. When the pulses interfere destructively, the amplitude of the resultant pulse is the sum of a positive number and a negative number, and hence is smaller. And when the pulses have the same amplitude but interfere destructively, the amplitude of the resultant pulse is zero. Note carefully that the pulses add up only momentarily. After they interfere, they continue to travel with their original amplitude.
Starting to feel it? Now go master it with Mesky.